What's up, everybody, and welcome back to another math puzzle. In this one, the question is as follows. Find the value of digits A, B, and C using the information below. So these are two-digit numbers, right? So we got AC plus CB plus BA equals 88. And then we've got a second little equation here, which is BA plus AC equals 39. So again, we're not adding the digits individually, but this becomes a two-digit number when these letters are put side by side like this. Hit that pause button and see if you can figure it out. When you're ready, hit play and I'll give you the explanation. So the first thing you might notice when you look at this problem is that for this left equation, in each column, we basically have the same thing. C plus B plus A, C plus B plus A. It's the same digits, but in different orders. And again, we remember with the commutative property of addition, it doesn't matter the order, you're gonna get the same result no matter what, which means that definitively we know that A plus B plus C must equal 8. Now again, remember these are digits, and when they're digits, that means we only have 10 possible values, right? 0 through 9. So since the sum of these adds up to 8, we know that 9 cannot be one of them. We also know that 8 likely cannot be one of them unless the other two are 0, but that wouldn't make sense with respect to this second one. So we'll eliminate 8 as well. So now we know we've got between 0 and 7 for these possible digits. Now the other thing that I notice here with this subtraction is A minus C is 9. So how do we get in that position where A minus C can equal 9? Obviously, one way this would work is if A were 9 and C were 0, right? 9 minus 0 is 9, but we've already eliminated 9. So what's the other way that we can get 9 here? Well, the other way is if these are 1 apart, meaning A is actually less than C. If A were 4, for example, and C were 5, we'd have to borrow from the B, make that 14. 14 minus 5 is 9. Okay, so once again, that tells me that C is equal to 1 more than A. Now, one more equation that we can generate from this subtraction problem is as follows, right? And again, remember I said this is a two-digit number. B is in the tens place, A is in the ones place. A is in the tens place here, C is in the ones place. So to turn this into a full-on equation, since B is in the tens place, the value of B is really 10 times B. The value of A in the one spot is just A minus, and then this one, which is 10A plus C, right? We're minusing that entire two-digit number, gives us 39. Now we have 3 unknowns and 3 equations. That's a really good spot to be in. Okay, now let's simplify this bottom equation down here. So as we distribute the negative and combine like terms, we now have 10B, and then it's A minus 10A, which is minus 9A. The minus distributes to the C, and that's minus C, and all of this equals 39. Okay, so I know we're a little cramped on space here, but here are 3 equations. That one, this one, and this one. So what I like to do when we have a triple system of equations is kind of combine 2 of them to eliminate one of the variables. I'm probably going to try and eliminate C, and then we're going to combine another pair, maybe these 2, and again try and eliminate C. Then we'll get a system of 2 equations with 2 variables, which is very solvable. So for these 2, I can substitute 1 plus A in for C, and we've eliminated the C. So then I'd have A plus B plus 1 plus A, again replacing the C, equals 8. And then as we combine like terms, A plus A is 2A plus B. And instead of having that 1 there, I'm going to subtract 1 from both sides and say that this equals 7. Okay, so we got this fantastic equation. Now we're going to do the same thing with this and this. So we're going to substitute in for C 1 plus A, so let's write that out. So instead of the C, I'm going to say minus 1 plus A, and this equals 39. Now we're going to distribute that negative and combine like terms. So we have 10B, and then that minus is going to go to the A, so it's negative 9A minus A, which is minus 10A. And again, we're still going to have a minus 1 here, but I'm going to add it to the other side to make that 40. Now, last but not least, just to simplify this equation, I'm going to divide everything by 10. That works out conveniently. So then now we have 1B, and notice I'm putting the B under the B here. We've got negative 1A, okay? And then on this side, we've got it equal to 4. Now look how really nice and simplified this becomes, because now we can use elimination to finally solve for B here. So what I'm going to do is I'm going to multiply this bottom equation by 2. So I'm going to say 2 2, and double the 4 to 8. Remember, with any equation, as long as we multiply everything in the equation by the same number, that is totally allowed. Now we're going to add these together. These are going to cancel out. B plus 2b is 3b. 7 plus 8 is 15. If 3b equals 15, dividing both sides by 3, we now know that b equals 5. Now if I know that b equals 5, I can plug it in here and say a plus 5 plus c equals 8. Subtracting that 5, I can say a plus c equals 3. So now that I know that a plus c equals 3, and I know that c equals 1 plus a, once again, I can substitute 1 plus a back in for c over here. So let me try to write this down here. We got a little bit of room left. So we've got a plus 1 plus a equals 3, and then a plus a is 2a, and then I'm going to minus 1 from both sides. 2a equals 2. Divide both sides by 2, and now we've got a is equal to 1. Last but not least, we know we can find c using this equation. Plug in 1 for a. 1 plus 1 is 2, which means that c is 2 for the win. Boom, done. Now plugging all this back in just to verify that it works, you see that up top we get 12 plus 25 plus 51, and that of course does add up to 88. Over here with the BA, we get 51. AC is 12. 51 minus 12 is indeed 39. That's how you do it. I hope you guys enjoyed this math puzzle, and if you did, please click that like button. If you want to see more math puzzles on the regular, make sure to click subscribe. Thank you guys so much for joining. We'll see you in the next video. Take it easy.